Ever wonder why you're not floating into space right now? Why the ground feels solid under your feet? The answer is hidden in 4 invisible rules that run the entire universe. Gravity keeps your feet on the floor. Electromagnetism holds your body together. Strong force locks atoms in place. Weak force controls decay. Without any one of them, you wouldn't be here. So why do these forces exist? Why 4? And what would happen if one of them changed, even just a little? In this video, I'll explain step by step, no complicated physics degree required. All 5 reasons will be revealed later in the video. You'll change everything you've ever believed.
I see stars, planets, galaxies. Everything seems so stable, so permanent. What holds it all together? It can't be glue. So there must be something invisible, some kind of grip that keeps the universe from flying apart.
4 fundamental forces. Gravity, electromagnetism, the strong nuclear force, the weak nuclear force. They are the invisible hands that sculpt the universe.
4 forces? But why 4? Why not 1? Why not 100? Is there something special about the number 4? Or is that just how many we've managed to detect so far?
Five purposes. 5 reasons why the universe needs these forces. Each force has a unique job. Without any one, the cosmos would be unrecognizable. But here's the deeper question. Are these forces truly fundamental, or are they different manifestations of a single underlying law? That's the question that drove Einstein for 30 years, and it's still driving physicists today. Without gravity, no stars, no planets, no galaxies. Gravity is the weakest force, but it dominates on large scales. It built the cosmic web.
But you said gravity is the weakest. How can the weakest force be the most important? That sounds backwards. The weakest force should be the most forgettable, not the architect of the cosmos.
Because gravity never cancels out. It only adds. A magnet can lift a paperclip against Earth's gravity, but gravity affects everything. It accumulates. Over cosmic distances, it becomes unstoppable. Gravity is also unique among the forces in being purely attractive. There's no such thing as anti-gravity or negative mass that pushes away. The other forces have positive and negative charges that can cancel out. Not gravity. It just piles on, forever.
So gravity holds planets in orbit. It holds galaxies together. It built the cosmic web. That's its purpose. It's not just a force, it's the sculptor that shaped the large-scale universe from a nearly uniform soup of particles into the complex structures we see today.
Gravity is the architect. It builds the largest structures in the universe. Without it, the cosmos would be a diffuse fog of particles. Reason 2. Electromagnetism. It binds electrons to nuclei, creating atoms. It binds atoms into molecules. It creates chemical bonds. Without it, no molecules, no chemistry, no life.
Electromagnetism is everywhere. Light itself is an electromagnetic wave. Radio, microwaves, X-rays, all the same force. So when I look at a star, I'm literally seeing electromagnetism carried across the universe and decoded by my eyes?
Water, DNA, proteins, all are held together by electromagnetic bonds. Every chemical reaction in your body is governed by electromagnetism. It is the force of life. And consider this. The entire visible universe, everything you see with your eyes, is revealed exclusively through electromagnetism. When you look at a galaxy, you're not seeing the galaxy itself. You're seeing the electromagnetic radiation it emitted millions or billions of years ago, finally reaching your retina. Our entire visual relationship with the cosmos is mediated by this one force.
So electromagnetism is the force that makes chemistry possible. Gravity builds the stage, but electromagnetism writes the script of life. But if it's so strong and infinite like gravity, why doesn't it dominate the universe the way gravity does? Why doesn't it pull everything together?
Because unlike gravity, electromagnetism has two charges, positive and negative. They cancel each other out over large distances. The Earth is electrically neutral, so gravity wins on cosmic scales. But up close, electromagnetism is a titan, and it has a rival even stronger, hidden deep inside the atom, the strong nuclear force. Reason 3. The strong nuclear force. Inside every atom, protons repel each other. They are all positively charged. Without something stronger than electromagnetism, the nucleus would fly apart.
Protons repel each other? But they're stuck together in the nucleus. Something must hold them. If the electric repulsion is trying to tear the nucleus apart, whatever holds it together must be incredibly strong, and it must act only at very short range, or we'd feel it everywhere.
The strong force is 100 times stronger than electromagnetism. It binds quarks into protons and neutrons. Then it binds protons and neutrons into nuclei. Without it, no atoms beyond hydrogen. But here's what makes it truly bizarre. The strong force gets stronger with distance, like a rubber band. If you try to pull two quarks apart, the force between them increases until the energy becomes so great that new quarks pop into existence out of the vacuum. You can never isolate a single quark. They're permanently imprisoned inside the particles they form.
So without the strong force, the universe is just hydrogen. No carbon, no oxygen, no iron, no life. Every element heavier than hydrogen, the carbon in our cells, the iron in our blood, the oxygen we breathe, exists because of the strong force.
Because the strong force has a hard border. It works only within the nucleus, about the width of a proton. Beyond that, it shuts off completely. It's a prison guard, not a cosmic emperor, and this limitation is crucial. It lets electromagnetism build the world of chemistry outside the nucleus. But there's another force that dares to cross this border, the weak force. It enters the nucleus and changes what's inside. Reason 4. The weak nuclear force. It governs radioactive decay. It allows protons to turn into neutrons and vice versa. Without it, stars could not shine.
Protons turning into neutrons? That's how stars fuse hydrogen into helium? So the weak force is the reason stars shine at all. Without it, the first step of fusion is impossible. The sun would be a cold ball of hydrogen.
In the sun's core, the weak force allows a proton to turn into a neutron, emitting a positron and a neutrino. This is the first step of nuclear fusion. Without it, the sun would not shine. But the weak force is also responsible for a phenomenon that literally keeps the Earth alive. The radioactive decay of uranium, thorium, and potassium in the Earth's interior generates about half of the planet's internal heat. Plate tectonics, volcanoes, the magnetic field that shields us from solar wind, all partially powered by the weak force. It doesn't just make stars shine. It keeps planets geologically alive.
And radioactive dating? Carbon dating works because of the weak force. It's how we know the age of fossils, of rocks, of the Earth itself. So the weak force is both a cosmic clock and a geological engine. It powers stars and gives us a way to measure deep time.
Because a perfectly stable universe would be a dead universe. Decay is transformation. It recycles matter. It heats the Earth's core. It lets us date the past. More importantly, the weak force breaks symmetry. It treats left and right differently. This asymmetry may be why matter exists at all, instead of being annihilated by antimatter. The weak force is why there is something instead of nothing. Reason 5. Balance. The four forces have vastly different strengths. If they were even slightly different, the universe would be uninhabitable. Too much gravity and the universe would collapse. Too little and it would fly apart.
The strengths are perfectly tuned? Is that a coincidence? Because it doesn't feel like one. It feels like the universe is balanced on a knife edge, and if any of these numbers were slightly different, we wouldn't be here to notice.
If the strong force were 1% weaker, no carbon would exist. If it were 1% stronger, hydrogen would fuse too easily. Stars would burn out too fast. Life requires a narrow window, but physicists are divided on what this means. Some see evidence of a multiverse, an infinite ensemble of universes, each with different force strengths, and we simply happen to live in one where the numbers work. Others argue that we'll eventually discover a deeper principle that makes these values the only mathematically consistent possibility. The fine-tuning problem is either a profound clue about reality or a profound illusion created by our limited perspective.
So the universe is fine-tuned for life? The forces are exactly as they need to be for us to exist? Whether by design, by coincidence, or by the logic of some deeper physics we haven't found yet, we're here because the numbers allow it.
That's the deepest question in physics, Minto. Some call it the anthropic principle. We see the forces as fine-tuned because if they weren't, we wouldn't be here to observe them. But there may be a deeper answer. Maybe the forces only appear separate. In the first moments of the Big Bang, they were all one. Their values were locked in when that unity shattered. The real question isn't who set the dials, it's why the unity broke. But here's the deepest mystery. The forces were not always separate. In the first fraction of a second after the Big Bang, at unimaginable temperatures, all four forces were united. One superforce.
One force? All four were one? What happened? So at high enough temperatures, the distinctions between the forces simply melt away? That suggests the separation we see now is temporary, a frozen accident from the cooling of the early universe.
As the universe cooled, the unified force broke apart. First, gravity separated. Then the strong force split off. Finally, the electromagnetic and weak forces parted. This is called spontaneous symmetry breaking. We've actually confirmed part of this experimentally. The Large Hadron Collider recreated the conditions where the electromagnetic and weak forces were unified, the electroweak era, about 10 to the power of minus 12 seconds after the Big Bang. We've seen the unification of two forces. The next goal, the grand unification with the strong force at energies a trillion times higher, remains beyond our current machines.
So the search for a theory of everything is the search to reunite the forces, to find the original superforce. And we've already succeeded with two of them. The electroweak unification earned a Nobel Prize. We know the pattern works. We just need to extend it.
And that's the dream, Minto. Einstein spent his last 30 years chasing a unified field theory. Today, string theory, loop quantum gravity, they're all attempts to finish his work, to read the first sentence of the universe's story, because if we can unite the forces, we won't just understand how the universe works. We'll understand why it exists at all. 5 reasons, 4 forces, 1 universe. Gravity builds the stage, the cosmic architecture. Electromagnetism writes the script, the chemistry of existence. The strong force forges the actors, the elements themselves. The weak force powers the drama, the stellar engines and the arrow of change. And their impossible, perfect balance lets the story unfold. A story that, after 13.8 billion years, produced a species that can ask why the stage was built at all.
So the 4 forces are the pillars of reality. Each has a unique job. Together, they create the universe we inhabit. Gravity shapes the cosmos. Electromagnetism lights it. The strong force builds its matter. The weak force powers its engines. Remove one pillar, and the whole structure collapses.
Gravity builds large structures. Electromagnetism creates chemistry. The strong force holds nuclei together. The weak force powers stars, and their balance allows life. But here's what's remarkable. We understand each of these forces through different mathematical frameworks. General relativity for gravity, quantum field theory for the other 3. They use entirely different languages, continuous space-time for one, discrete particles for the others. The fact that these 2 descriptions of reality coexist in the same universe, producing the same correct predictions in their respective domains, is one of the great puzzles of physics. They're both right, but they can't both be fundamental. Something has to give.
And each force is perfectly tuned. Not too strong, not too weak. Just right for us to exist. Whether that tuning is evidence of a multiverse, a deeper mathematical necessity, or something we haven't yet imagined, the fact remains, we're here because the numbers work.
That's the spirit of a true scientist, Minto. We've mapped 4 forces, but the universe loves surprises. Some experiments hint at a 5th force, a dark photon, or a particle called the X-17. We don't know yet. But every force we've discovered was once invisible, waiting for the right question to reveal it.
We are the children of these forces. The gravity that holds galaxies also holds our feet to the ground. The electromagnetism in lightning is the same force that fires our thoughts. The strong force in a star is the same that binds the atoms of our bones. We're not just in the universe is in us.
The fact that we, collections of particles governed by these same forces, can stand back and understand the rules that created us, that is perhaps the most extraordinary phenomenon of all. The universe has produced a part of itself that can comprehend the whole. 4 forces. Gravity, the architect. Electromagnetism, the chemist. The strong force, the nuclear glue. The weak force, the stellar engine. Together they create, sustain, and shape the cosmos.
The universe is not chaotic. It is ruled by 4 invisible hands, and they are perfectly balanced. Not just balanced, they are what make the difference between existence and nothingness.
That's what I do, my boy. I help you see the invisible hands. The forces are the language of the universe, and you are beginning to speak it. And the more fluent you become, the more you realize these four forces are the closest thing to a cosmic grammar, the rules that make all other rules possible.
The forces are the rules of the cosmic game, and we are learning the rules. And the players, us, are made possible by the very rules we're studying.
The fundamental forces. They are the reason the universe is not a void. They are the reason there is structure, order, and life. And they are the reason we can ask why. The forces are the rules of the cosmic game.